Greetings, my name is Charles Simon, and I'd like to introduce you to a new open source software project called the Brain Simulator 2. It's a spiking neural simulator with the added ability to easily create custom modules which can perform any desired function. In this video, I'll describe the project strategy, the software functionality, and the current test applications in the project. What does the Brain Simulator have to do with artificial general intelligence? Today's AI falls short of AGI, and many of the missing components are things any 3-year-old can do. Playing with blocks, Sally can comprehend that physical objects are solid and persist in reality. She knows that causes lead to effects over the passage of time. She understands that a stack must be built before it can fall down. She knows these things because she has multisensory input and can interact with objects in her environment. I see these basic capabilities common to any 3-year-old are missing from today's AI and are fundamental building blocks for AGI. Concepts such as physical objects and time I see as necessary components. Whether they are sufficient to create AGI remains to be seen. So, the Brain Simulator 2 project is targeted at trying out ideas on these problems, with software modules built on a neural simulator. The neural simulator includes integrated fire and leaky integrated fire neural models. There is a powerful user interface supporting many millions of neurons and synapses on a desktop CPU. Above this base, over 40 modules have been developed, and these provide for the senses of vision, hearing, and touch. For development, there are simulators in 2 and 3 dimensions, and for interfacing with the real world, there are modules for robotics and camera and microphone input. There are modules to handle behaviors of speech, moving about, and moving objects in the environment. Internally, there are modules for maintaining an internal spatial model of physical objects in the nearby environment. And finally, the Universal Knowledge Store merges and stores all this multisensory input. Information is stored in the form of relationships between nodes in a graph structure. With these combined abilities, there is a basic virtual entity I call Sally. Sally can hear, speak, see, and touch her environment. Today, Sally lives in 2 dimensions, but when Sally seems to comprehend objects in her 2D environment, we can advance to 3D or real-world senses. Everything Sally learns is retained in the Universal Knowledge Store. Within the Brain Simulator project, there are a number of test applications. For details on these applications, each has its own YouTube video, and I encourage you to explore them. For example, Sally can traverse mazes by recognizing landmarks, making decisions, and remembering the outcomes of those decisions. Sally can learn phonemes, words, and phrases and associate words with actions or physical objects and their attributes.
Daddy.
Sally can see objects and estimate distances with binocular vision. Sally can push an object to a goal location. The key is that these different applications share many algorithms. In summary, Brain Simulator 2 is a high-performance, open-source project for AGI research. I encourage you to visit, try it out, make comments and suggestions, and to follow along to see how the project evolves. Thank you for your time and attention.